In this video, I'd like to talk about the math question of the day for February 19th, 2023. And with this problem, we are given the graph of a function, and we need to find that function's domain and its range. So to answer a question like this, you need to have a solid understanding of Algebra 1 and most likely Algebra 2. And at this point, go ahead and pause the video, see if you can work through this on your own, and when you're ready, we can go through this together. Now, assuming that you have at least attempted this problem, we can work through it together. And as always, if you do have suggestions for future questions of the day, feel free to leave those suggestions as a comment down below. Now, when dealing with domain and range, we are essentially asking ourselves which x values are a part of the graph and which y values are a part of the graph. So we can simplify these concepts. Domain, you can essentially ask yourself which x values are graphed. There is a more complicated definition for this, but in terms of graphing, this is a simple way to define it. Now with the range, it's pretty much the same, but dealing with the y values. So we can ask which y values are graphed. And if we had equations, this question would be more challenging. But since we have a graph, we can just confirm things visually. So we can start with domain, which x values are actually graphed here. And we want to find either holes in the function or endpoints of the function and use that information. For instance, if we had some hole in the function, let's say right here, then that particular x value and y value is not a part of this graph. But in this case, it doesn't look like we have any holes, so we don't have to worry about anything too difficult. But we do have this endpoint right here, and this point has an x value of 0 and a y value of -1. Notice that it is the smallest x value. In fact, anywhere on the left half of the coordinate plane, you don't see any graph, meaning that none of those x values are actually graphed. So the starting x value, the lowest possible, is at 0. And since this is actually filled in, it looks like we're including 0 as part of the domain. And then from there, the x values increase, but the curve increases as well. And it looks like this curve will continue forever. So for the domain, which we can call D, the x values start at a smallest value of 0, but then essentially go on forever, increase towards infinity. So this is one way to write it. This is the inequality notation, but we can also use interval notation. We can say the starting value is at 0, and we use a bracket to actually include it. And it goes all the way to infinity, which we use parentheses for, since you can never include infinity. It's a concept, not a number. But if 0 wasn't included, then we would use a parentheses there instead. So our domain, the x values go from 0 all the way to infinity. Now, with the range, R, we look at the smallest y value, which looks to be the y value of this point right here. Since anything below that, y values below -1, there is no function. So it looks like our range starts at -1 and then increases towards positive infinity. Since again, this curve, it looks like it's going to go on forever. And the y values might go up slowly, but it doesn't seem like there's any reason that they would stop increasing. We aren't given any more information. So it looks like our range starts at -1 and, like the x values, goes towards infinity. And that's using the interval notation, but if we want, we can use inequality notation, like so. And if we wanted to be really careful, since technically we don't know what happens to the graph, then we can report domain and range just based on what we see. Because in some sense, the function could sharply curve down or do all kinds of crazy things after this x value of 6. So if we want to go off the graph, the x values go from 0 to 6, and the y values go from -1 to right about here, which we can maybe say is 2.4 or so. But again, that's just based on the picture, though it does seem like this function is increasing or continuing forever. Since if you recognize it, this actually just looks like a square root function where everything was shifted down 1 unit. And that would actually make sense because if we plug in a value here, let's say 4, we get 2 minus 1, which would be at a y value of 1. So it looks like this function that's graphed is really the square root of x minus 1. But with these types of problems, we don't need to actually determine the equation. We just need to look at what the x and y values are doing in the graph.